All right, everyone, welcome back. We have 3.4, rewrite quadratics by completing the square. And your only learning goal is to rewrite quadratics by using the completing the square method. Now, just a quick look here. Notice how it says rewrite. You can solve with this method, but we're going to kind of stop short of doing that, and hopefully I can help you understand why in this lesson. Okay, so we have more options, a little bit of math talk here, right? When you get to this x squared plus 6x is equal to -2 situation, I know we could, add 2, we get x squared plus 6x plus 2 is equal to 0, right? We do our x factor, we have 2 and 6. Well, what times what gives you 2 that adds to be 6, right? And we run into this situation here, okay? And we know at this point, quadratic formula, we'll always get an answer, but there's a lot of variable amount of work for that quadratic formula. It's a lot of steps. There has to be something more simple that we can do, right? And that's where we have completing the square. So the whole point of completing the square is creating a perfect square trinomial by adding b squared over 4a to both sides, okay? Now, what is a perfect square trinomial? Let's look at that right here. A perfect square trinomial is essentially the same binomial times the same binomial. So if I were to write this out as an actual equation, it'd be like x plus 2 squared, which is the same thing as x plus 2 times x plus 2, which would then give you x squared plus 4x plus 4. Now, it's a complete coincidence that this number and this number are the same number. Okay, that doesn't mean that every perfect square trinomial needs to be that way. So let's do it with 3. X plus 3 squared equals x plus 3 times x plus 3, which will then give you x squared plus 6x plus 9. Okay, notice this pattern though. The same number ends up being added to give you your b term, right? That also ends up being multiplied to give you your c term. That's really the characteristic of a perfect square trinomial. These things are awesome. They're super clean, they're super neat, they're pretty looking, right? And they're really, really helpful because we can instantly go to their factors. If I identify that the same number is added for b that's multiplied for c, well, then I could jump into a binomial squared. Now I can open up another method like solve by square root, okay? So let's do that. Let's add, so let's go x squared plus 6x, and let's add b squared over 4a to both sides. Like that, okay? I'm gonna put that in purple. Remember, in order to keep your equation valid, you need to do the same exact thing to both sides of the equation, okay? So let's fill it in with the answer. So b would be 6, a would be 1, so this would be x squared plus 6x plus 6 squared over 4 times 1, okay? And that would be the same exact thing over here, and when we simplify this, x squared plus 6x plus 36 over 4, or really just plus 9, okay? So let's put that over here. It's just a plus 9, okay? So now we have x squared plus 6x plus 9 is equal to positive 7, because -2 plus 9 is 7. Now let's look at this, okay? We have a perfect square trinomial here, right? 3 plus 3 is 6, 3 times 3 is 9. Awesome. And it's equal to 7. Now normally we're like, oh, it's equal to 7. Like, let's get that set equal to 0. But because we completed the squared, we can rewrite this as x plus 3 squared is equal to 7. Okay? Now, how did I jump to that? I jumped to that because I could see me, doing this a lot. I could see the same number being added for b that was multiplied for c. You could still use your x factor, right? You would have had 9 up top, 6 on the bottom. 3 times 3 is 9. 3 plus 3 is 6. Everything's great there, right? And jump into your factors. And this is where we're going to kind of stop with completing the square. Now, the reason why is, in previous methods, you would, I can solve by square root here. I can take the square root of both sides. I can get an answer for x. And that's true. And we've done that in a previous lesson. But there's some other goals, that we would get out of completing the square. it's more of an intermediary. It's something that we use to go between different methods. And what I mean by that is we had a quadratic up here. We used completing the square to bring us to a situation where solve by square root makes sense, okay? And we're also going to look at a situation for graphing where it makes sense, okay? All right. Okay, so looking at this real quick in this problem, sorry, I know I'm jumping right back. We set it equal to 7, and that's fine. It was kind of more to kind of set it up for solve by square root, which is something we can do. But in this time, we're going to do this a little bit different. Now you can see you have a trinomial, right? And, well, you know, the previous problem, it was set equal to a different number. Either of those are acceptable times to use completing the square. The way we're going to do this, we're going to ignore this 27 for just a little bit, okay? Now, if you try to factor this, again, you're not going to get very far. What times what is 27 that ends up being -8? Good luck trying to figure that out, okay? So let's use completing the square to rewrite this for maybe graphing or for maybe solving by square root, okay? I'm going to set this equal to 0, so if 0 is equal to x squared minus 8x, and then I'm going to add, and I'm going to put a space here for 27 because I want to add b squared over 4a to both sides. So over here to the side, let's do that. B squared over 4a. So b is -8, so we would have -8 squared over 4 times a, which is 4 times 1. And -8 squared is 64. 4 times 1 is 4. You end up with 16. Okay. So we need to add 16 to both sides. I'm going to put that there. Okay. Now again, I'm not going to combine those like terms. I'm not going to combine these because if I do, I no longer have a perfect square trinomial, which is what we want. So I'm going to deal with this first, okay? You're going to have 16 is equal to, now I can see off the bat, because we're thinking of perfect square trinomial, I know they have to be the same number. I see a -8, I instantly think -4 plus -4 is -8. -4 times -4 is 16. If you have a hard time seeing that, you can still x factor 16, -8, -4 times -4 is 16, -4 plus -4 is -8, right? When you have that same number, that means you can really just write it as one binomial squared and then put your other term, plus 27, okay? All right, now where do we go from here? We want to set this up like it's a vertex form problem, so we need everything to one side. So we're going to minus 16. We're going to get 0 is equal to x minus 4 squared plus 11, okay? And now we're going to re-put our f of x back like we're no longer solving for 0. So f of x is equal to x minus 4 squared plus 11, okay? And this would be our final answer. And look at that, that's in vertex form, okay? Now, you know, what's kind of the point here, right? The point is that we can really unlock two different steps. At this point, if we wanted to, we could have solved by square root, right? We would have actually brought the 27 to the other side to get -11, square root both sides, we can get to x. Or we can set things up in vertex form if you want to graph, okay? Now, you know, in my personal preference, I like to graph in vertex form because I can immediately see the vertex, right? And instead of using standard form by doing the axis of symmetry and then plugging it in, you know, I like to already know my vertex without having to do that work, okay? All right, let's give you guys, real quick, this needs to be, for this lesson, needs to be your final answer, okay? So here's one for you guys to do. Give it a try, and then I'll do it. Okay. So hopefully you didn't try to use a different method or just rewriting. So we're going to find out what our b squared over 4a is. So we get 10 squared over 4 times 1, which would give us 100 over 4, which would give us 25. So I need to add 25 to both sides. So because I know g of n is going to be 0, I really just have 25 on that side now. Is equal to n squared plus 10n plus 25 plus 4. Notice how I move that 4 over to the side for a second here, okay? And then I need to kind of factor my perfect square trinomial, I see 5 plus 5 is 10, and 5 times 5 is 25. If you need to use the x factor, do so. 5 times 5 is 25, 5 plus 5 is 10, and so this is going to be n plus 5 squared plus 4 is equal to 25. Okay. At this point, you get it equal to 0. Subtract that to both sides, and you're going to get, we'll make this f or g of n, excuse me. We're going to have g of n is equal to n plus 5 squared, and then we minus 25 for negative 21, and this would be your final answer. Okay, now I'm going to go over another method on kind of how to work this out just a little bit faster. Okay, and sometimes you show too many methods and it confuses a lot of people, but I think some of you are probably realizing the redundancy of the extra steps already, and I'm going to show you how to mitigate that in the next problem. Okay, but hopefully this is the answer you got. And also what we're going to introduce in this one is having an a value. In the previous two, you noticed that we didn't have an a that was greater than 1, and so we're going to kind of work that in on this one. All right, and I'm going to show you kind of both ways, the long way that we've been doing, and then the shorter way that we can figure out. Okay, so first things first, we need to find out what b squared over 4a is. So we actually have an a now, which is nice. So we're going to get 8 squared over 4 times 4. 8 squared is 64. 4 times 4 is 16. This simplifies to 4. So you would need to add 4 to both sides. So we're going to get 4d squared plus 8d. Excuse me, this is, well, let me just redo that. Okay. I'm going to make m of d to be 0. So it'll be 0 plus, what is happening? Okay. 0 plus 4 is equal to 4d squared plus 8d, okay, plus 4 minus 24. Okay, notice how this is where that plus 4 came in. All right, now when you look at this and you try to work out your perfect square trinomial, it's a little bit harder to think about what those numbers would be. Okay, so here I would recommend doing the x factor. A times c up top, 4 times 4 is 16. 8 is on the bottom. 4 times 4 gives you 16. 4 plus 4 gives you 8. Okay, that's good. But we can't just call this d plus 4. There's still that a value. So we're going to use that factor by grouping, okay, which I know no one's really looking for here, but we're going to use factor by grouping to figure this out. Okay, so you would have 4d squared plus 4d plus 4d plus 4. It's a lot there, right? Then you group and you group and you group. You end up with 4d. You divide that out. So you should end up with d plus 1. And then again, we have 4. And so plus 4 times d plus 1. Okay, that's good. So our perfect square trinomial, or kind of perfect square trinomial, we get 4d plus 4 times d plus 1. Okay. What did I mess up here? Did I mess something up? Not exactly. Okay. So again, a perfect square trinomial is supposed to have the same exact binomial squared, right? But we can see that we don't have the same exact binomial squared here. But if you look at this binomial, you can see that there's another greatest common factor of 4. So let's divide out that 4. So divide by 4, and we're going to get 4 times d plus 1 times d plus 1. Okay, or really just 4 times d plus 1 squared. Okay, that was a lot more work, right? And that's all right. Now let's bring in our other stuff here. All right, so I'm going to that was the end of that part. We are now back to 4 is equal to 4 times d plus 1 squared minus 24. All right, we're going to set this equal to 0, so minus 4 minus 4. You end up with, I'm going to get rid of the 0 again, so m of d is equal to 4 times d plus 1 squared minus 28. Okay. All right. That was a lot more work. That's okay. There are some other ways to kind of do this, and we won't be able to talk about them in this video, but maybe we could talk about them in class. All right. Now, the one brief way I'm going to show you to kind of simplify this is an early step. All right. When you added that b squared over 4a to both sides, we ended up with this. We did 0 plus 4 is equal to 4d squared plus 8d plus 4 minus 24. Okay. And you notice how at the end here, we always take that term and do the opposite, right? So we always know we're adding b squared over 4a, and then we're going to subtract it to the other side when we get to the end. So why not do that early on? If we know we're just going to minus this over here, well, technically we want to put it on the end, right? Then why don't we just do this? From the very, very beginning, 4d squared plus 8d plus 4 minus 24, and then already subtract it over. Another way of looking at that is and if we kind of wrote this with the formula so you can see, is you do 4d squared plus 8d plus b squared over 4a minus 24 minus b squared over 4a. Why not do that, right? We know that if we would have added it on the left side, eventually we would have to subtract it. You just have to make sure you subtract it from that other term that's now being kind of pushed away from the trinomial, okay, or subtract it. Now, if this confuses you, you don't need to do this, all right? But if you're like, oh, thank God I simplified the step and I want to do less work, then do this, okay? All right, here's one for you guys to try. Give it a try, and then we'll go over it. All right, hopefully you gave this a try. Let's go over it. We got the b squared over 4a, which is going to be 12 squared over 4 times negative 4, which is going to be equal to 144 divided by negative 16. 144 divided by negative 16 should give you negative 9, okay? Now, in the previous problems, we were always told to add to both sides, right? Well, now we're adding a negative, so it's kind of like minusing to both sides. So we're going to have 0 minus 9 is equal to negative 4w squared plus 12w, and then we'll have to minus 9 right here, and then we have another minus 9, okay? So this one was kind of already set up as a perfect square trinomial, right? Because we already had a minus 9 there, and we didn't even know it, okay? Now, we're still going to do this the same way. It should work out. Watch this. You add the 9 here, you add the 9 here, because that was not part of it. Those cancel, and we're left right back with our original problem. So we know we already have a perfect square trinomial, which is awesome, okay? So let's just go right into figuring that out, okay? We're going to use our x factor. Negative 4 times negative 9 is positive 36 over 12. And so 6 times 6 is 36. 6 plus 6 is 12. So we're going to have negative 4w squared plus 6w minus 9 is equal to 0. And then we factor by grouping. So we need to take out a negative, what? Let's see. A negative 2. Yeah, I'm going to do a negative 2w. You could have done a positive and then done the opposite for the other one. It's all going to work out the same way. Okay. So I have negative 2w. I divide it out. I get 2w, right? Minus 3. And then over here, I need to take out 3. And I should get, let's see, plus 3 times 2w minus 3. Awesome. Now here, look what happens. We end up with negative 2w plus 3 times 2w minus 3. Okay, so these are opposites here. And remember, we need a binomial squared. So what we really need to do is just take out a negative 1 out of one of these. Okay, I do that, I get negative 1 times positive 2w minus 3 times 2w minus 3. I have the same binomial squared, so this is negative 1 times 2w minus 3 squared. Now, because that other term here got eliminated, right, there is no, k value if this was in vertex form. So k of w is equal to this. Now, that was a tricky one, probably because of that early curveball, right? It just meant that we had a perfect square trinomial off the bat, okay? All right, let's finish this off. there's two reasons why we want to use this method, okay? The starters, if we're solving versus if we're graphing, okay? If we're solving with this method, then, and we have something, x squared, what was that early one we had? This one right here, x squared plus 6x is equal to -2. You have something like this, it's not even in standard form, you can complete the square and get to the point where you use solve by square root, okay? Now, I think a lot of you would choose a different method than solving by square root here, or using the completing square to solve by square root. I think a lot of you would opt to use quadratic formula before this, or you would try really hard to factor. It's pretty hard pressed to find a situation where this is really the better idea when it comes to solving, okay? And this is why we didn't solve, okay? You may be wondering, like, all we have to do is just rewrite it. We don't have to tell what the answer is. Yeah, because you're probably not going to do this. You're probably not going to choose this to solve, okay? So then what do we really use this for? It's for graphing. If you have x squared plus 6x minus 2 is equal to 0, and this is in standard form, you have to find the x equals -b over 2a. You got to plug that into your function to get your vertex, okay? And, if there's imaginary numbers, it kind of complicates the situation a little bit here, right? Or we can convert this to vertex form. And when something's in vertex form, it is much easier to graph than it is in standard form. Or it's just much easier to see where things are heading, right? When it's in vertex form, you can tell so much about the equation, right? But when it's in standard form, you can only tell a limited amount of things off the bat. Is it up or down based off the a value? This -2 plays a little bit of a role, but it's not just a direct up and down shift, right? So vertex form, it's like everything is seen off the bat. I really like that, okay? So this right example is more of what we would use it for, and that's why you're not taking this all the way down to answers every single time, okay? So hopefully you enjoyed this video. I'll see you guys next time.